Good afternoon. The next speaker is Sébastien Rannou, and he'll tell us everything about real-time monitoring of our ETH validators.
Thanks. Hi. My name is Sébastien. I work at Kirn, which is a provider of Ethereum validators. So we work with Lighthouse, with Ledger as well, and others. And yeah, we'll be discussing a bit about how to monitor Ethereum validator at scale in real time. First we'll discuss a bit about monitoring from the inside, then about monitoring from the outside using the blockchain. We'll then have a quick look about the different signals you want to monitor, and maybe we'll have some time for questions at the end. So monitoring from the inside. So the idea about monitoring from the inside is like you are running an infrastructure of Ethereum and you have access to all the components from the inside. So you can directly measure different metrics such as like resources or also like CPU, memory, volume, networks. It kind of like depends on your setup. If you are using Kubernetes, you will have maybe different sets of signals here. I've listed here the typical components of an Ethereum stack. So you have like execution nodes, which are used to produce blocks. You also have like consensus nodes, such as, beacon nodes, basically, validator clients, Web3 signer, MEV boost, and so on. The idea about monitoring from the inside is that you are going to get for free a lot of signals. So it's going to be a bit noisy, and making sense out of it is a bit tricky. But as you are getting a lot of information, it's very helpful to help debugging and deep diving into like very specialized cases whenever they happen. Another disadvantage of monitoring from the inside is that if you are like working at scale, you probably want to encourage client diversity. So you're probably going to run different types of execution nodes, consensus nodes, and so on. And those nodes are going to expose different metrics. So for instance, the definition of the last block seen by a beacon chain like Teku may be different than the one used by Prism. And so if you try to aggregate those data together, they may not make sense. So this is where monitoring from the outside comes. And the idea about monitoring from the outside is that instead of looking at internal signals, you can directly look on chain what's going on. So you can look at the content of blocks and slots, try to extract information from there, and infer how your public keys are performing. This is just a small diagram of the previously mentioned components of Ethereum stacks. You have on the left MEV boost, which is typically used like for MEV and it's connected to different relayers. You have a pair of beacon and execution node to which a client connects. And so the client which loads validation keys is going to subscribe to the beacon, which in turn will subscribe to the MEV boost to get new block proposals. And so if you have internal monitoring, you will have like basically your monitoring connected to all of those and watching different signals. And so outside monitoring, on the other hand, is like you introduce a monitoring tool and you connect it directly to the execution node and the beacon node, and from there you are able to look at what's happening on the blockchain. So you actually don't want to connect it directly to the infrastructure you are using for validation keys because, let's say, I don't know, the beacon node is stalled or something, you won't be able to get information about new slots, and so you won't be able to monitor. So you want actually to have two separate stacks here. You want to have one stack for the validation path and one stack for the monitoring itself. So this is what I just mentioned. So the idea is just to like run a separate stack for monitoring. So at Kin, we developed a tool called the Ethereum VAR Watcher. It's a small Python tool which can connect to execution nodes and beacon nodes, and you can configure it with a list of public keys, and then it's going to look for different signals we are going to discuss a bit about later. It's open source, so like if you want to give it a try, you would be happy to have users. The tool can be configured either by giving it a list of public keys, or it can also be configured by directly connecting to a Web3 signer instance. And on Web3 signer, there is a small RPC call to get the the list of keys that are handled by Web3 signer. So that's basically it. Let's discuss a bit about the different signals you want to watch for. Most obvious one is missed blocks. So like proposing a block is in the lifetime of validator key something quite rare. Like it happens once every 4 months on average, I think, these days. And whenever you propose it, it's going to like correspond to all of the execution rewards you have for the 4 months. So you don't want to miss it. Yeah, there can be multiple reasons for missing a block. There can be an issue that does not depend on your own infrastructure. For instance, if you have like some issues with external relayers, and this is also where outside monitoring is quite interesting, because you will also catch issues that are outside of your infrastructure. So yeah, we expose like missed blocks. You also want to have a look at like missed attestations. So like this happens your validator has to propose a block. Has to sign an attestation every 6 minutes on average. And it's quite okay. Like if you operate at scale, you will often have a small tail of like missed attestation due to network hiccups or this sort of things. So this is quite a noisy signal, but it's quite important to have it at scale, so that like let's say like if 70% of your infrastructure is missing attestations, there is probably something going on. So this signal is noisy, but can be useful when running at scale. For issues that are related to very specific key, double missed attestations, that is like missing 2 attestations in a row, is a bit more interesting. It can, like, for instance, happen if you misconfigure your validator, or if it's not loaded properly by the client, you will have you will be able to alert on this. So basically, you have like 2 sorts of alerts on attestations. At scale, by looking at single missed attestations, and per validator key by looking at double missed attestations. And missing attestations, I've listed a few issues, possible root causes here, but there are others. Another signal is, so on Ethereum, whenever a validator signs for an attestation, it's like included in a slot, and there is something called the inclusion distance, which is like the distance between your attestations and when it's included on the beacon chain. And the higher the inclusion distance is, the lower the reward you are going to get. So it's also a signal you want to look for. So we also expose it here. And on like same as before, like this can happen because, I don't know, you probably like maybe you have like network issues with your beacon and it's not like propagating enough attestations, or it can also be like a network event where sync aggregators or other actors of the network are not like getting your attestation in time. And so like this graph here is like what happened when we had some finality issues a few months ago on the entire network. Another signal you want to watch for is untimely or bad source target head. So it's a bit similar to the previous one. You won't get the maximum theoretical number of like consensus layer rewards if you don't vote for the right source target or head. And so it's also a signal you want to monitor. And we are using like the rewards API, which was introduced I think a few months, like 6 months ago or something like this, on the Beacon RPC API. And you can quite easily know how much you could have theoretically made if you were like doing the perfect job versus how you are actually performing, and you can get an idea of your effectiveness, which is also the signal used by Beacon Chain, beaconsha.in. So that's another important signal to watch for is like if you are using MEV. So the way it works is like the beacon is going to ask like whenever one of your validator key has to propose a block, the beacon is going to ask to the relayer, typically via MEV boost, to get a header. And if the relayer does not reply in time, then the beacon is going to fall back to build a block locally using your local execution node and the public mempool. And so this signal here is like connecting to relays and checking if the block you just proposed is actually a block you built locally or using a relayer. So it can give you an idea if like you misconfigured MEV or something like this. Yeah, so another quite interesting feature is like, so it's not like a signal like that shows performance issues or whatever, but it's on the Beacon chain, you can know 2 epochs in advance if one of your validator is going to propose a block. And it's quite an interesting metric because when you operate at scale, you have upgrades to perform, you have to reboot validators and so on. So by looking in advance, if there is something that is going to be proposed in the next 2 blocks, next 2 epochs, sorry, you can decide or not to take this action. And it's quite like a simple way to increase your, to decrease your chances to miss a block. So if you are a big node runner, you probably also have like automation in place to exit validators. So it's just a simple metric to look for as well. And here's another one. So this screenshot is taken on Holesky, where we are one of the operators. So all of the signals I mentioned before can be a bit noisy on some networks due to the scale or like external reasons, external factors that may not be in your responsibility. And so if you are if you are seeing like high misses of attestations and all, it's always interesting to compare it with how the network is doing to know if it's actually something that happens because you are badly operating or because it's like something is going on the network. And so we also have the ability to watch for all keys of the network in real time, export those metrics, and be able to compare them with the set of metrics that are just for our validators. So as I said, like we have like this Python script that exports metrics to Prometheus, and then you can we also have a dashboard, a Grafana dashboard, which shows all of those metrics in a nice way. So this is a bit old because it was like a few months ago, where the NTQ were much higher than they are today. But if they ever grew, if the number of active validators increases, suddenly we will be you can also track the entry queue and exit queue times here. And there is also some other information like the AUM you are managing or whether or not you are slashed, which hopefully stays to 0. So yeah, as I said, it's like using Prometheus. So if you have alerting on top of it, you can for free get Prometheus alerts, and you can also directly connect it to a Slack channel, and it will output to you whenever something is going on your public keys, and you can also have some information from the log files. And yeah, some things we want to add soon. So we want to be able to have different labels per key. So the idea here is to say oh, this key is, I don't know, running on a specific region or data center with Prism or Lighthouse in this very, very specific version. And then the tool can export it as Prometheus labels. And then you can compare, I don't know, how this specific version of Prism is doing compared to this new one. And it can help a lot with qualifying new releases or network hiccups of, I don't know, running in Brussels versus Ireland or this kind of stuff. So it's not a feature we have yet implemented, but we are working on it, and we think we'll have it soon. And another one is the ability to backfill alter data, that is to run the tool against past range on the Beacon chain. And there are tricky ways to do it with Prometheus, but we think we can do it. And this would be helpful, for instance, for post-mortem analysis where you want to integrate a new signal and you want to see how it was performing at the time. Yeah, I think that's what I had to say. If you have questions. So yeah, there is a link to the open source version of the Ethereum VAR Watcher, which was initially written by Manu, who is not there. But yeah, feel free to scan the QR code to get access to it. And yeah, if you have questions, happy to take them.
Questions?
Hi, thanks for the presentation, really nice. You said you used the Beacon API rewards endpoint that was introduced some months ago. How do you plan to do that with all the data? Because I think it's a bit slow with, I don't know if you have any plan already or something.
Sorry, so the question is how fast it is to query this data, or?
Yeah, because right now that endpoint I think is really fast with data from finalized to the head,
Yeah.
But I think with all the data, it's not as fast. I don't know if you
Yeah,
already have.
for now, yeah, we are not like, so right now, like the tool is only running real time, so it doesn't have to go in past ranges. So yeah, I guess this is something we'll have to figure out if we want to go in past data.
I was just trying to know if you had any plan for the backfill feature.
Not yet. Like we have aggregators, like not here, but like internally, which are like being written to. So yeah, I guess one possible way is just to look at the effective balance. No, sorry. Sorry. As the active balance, you can like kind of like get an idea of the performances by taking snapshots of like your active balance at the end of the day, from beginning of the day, do the subtraction and some math. But it's not going to give you fine-grained signals. So yeah, I guess we'll have to find a way to make it fast if it's too slow. Like, do you have an idea of the order of magnitude? Like, is it like 10x slower or? Well,
I have a bit of experience using these endpoints, and it's a bit experimental, as you said, yet. So I also have some issues with backfilling.
Are you using Lighthouse or Prism?
Correct.
Okay. Lighthouse.
Maybe we can discuss it now in like petit comité.
Yeah, let's chat a bit about.
Thanks a lot for the answer.
Other questions? No? Okay. Let's thank the speaker again and see each other in about 10 minutes for the next talk.
Thanks.